Friends, welcome to our video presentation on building regression-based decision support models or systems in Excel. In this video presentation, I will show you how to build a simple decision support system based on regression analysis. Now, the essence of this model or decision support system is that we use regression modeling to predict price for real estate. So the idea here is this, from a practical standpoint, is that once a real estate agent, let's say, or government official responsible for calculating tax enters certain parameters for this regression model, or values for this regression model, such as number of rooms, number of bathrooms, area of the property in square feet, and condition, 1 or 0. 1 means good condition, 0 means poor condition. The model will calculate the price, the suggested price or recommended price based on the data that was analyzed with the help of regression model. So that's the essence. We're trying to predict price based on those independent variables. Now, I would like to say that there are probably much better ways of doing this. For example, you can include not necessarily a greater number of variables, but you may think about variables that make more sense, giving your particular situation, giving your particular case. So, for example, maybe you shouldn't include rooms. Maybe your theory is that rooms do not have that much of an impact on the price. Or maybe you can include additional variables. For example, some kind of variable that indicates location of a property. Let's say inside city limits or outside of city limits. Now, in your case, you need to use data that you generated as a result of web scraping for your assignment 1, where you downloaded all this data about real estate for sale in Murray. In my case, I'm using fake data, meaning I generated this data myself, 100 points, 100 values, specifically for this example. So don't be surprised if some of those values, they don't seem to be realistic or they don't make much sense. I'll just correct this value. So yeah, I just generated using like a linear equation with some, with some randomness for each of the coefficients. So I'm just telling you that this data is not real. So don't pay too much attention to the actual values. Although my hope is that my equation that I used to generate those values, it kind of makes sense. It's not perfect, it's not 100% real, but it kind of makes sense. Okay, so this is what you need to do. First of all, you need to have a tab that is called Data. So this is where you will store the data that you will use for regression analysis. Okay. So what you will do next, you will build your regression model. Before doing that, before subjecting this data to regression analysis, you need to watch the other 2 tutorials. The first tutorial that I recorded, which is about the theory behind regression modeling, and the second tutorial that I found on YouTube, which seems to be very good. It's specifically about building regression models using Excel. So this, among other things, that second tutorial also talks about the fact that the data analysis pack sometimes is not enabled. It doesn't come with Excel by default. So if it's not enabled, there are certain steps where you need to go to options and enable the data analysis pack. But in my case, data analysis pack is available right here. So what I will do, I will click on this data analysis pack, and out of those techniques, I will select regression. By the way, if you look at, if you took a course on statistics, and if you look at the collection of techniques, personally, I'm quite impressed, because it looks like Excel is not giving fair credit for containing all those statistical analysis capabilities as a part of the data analysis pack. In other words, Microsoft Excel can do a lot of statistical analysis for you to the point where for basic analysis you don't need to have a more sophisticated and expensive piece of software such as SPSS. I mean, for most researchers, for most data scientists, Excel has everything that you need. So look at all those statistical tests available here, but we'll select regression, so we'll press OK. Now, what we need to do, first of all, we need to specify the Y range, which is our dependent variable. So we'll do it like this, and we'll include price as our label, so that we have a more intuitive regression output. So this is our Y variable. Then we're going to specify the independent variables, the range for independent variables. Now this is our range. We'll select these values. Now we're not selecting the A column because those are just like numbers of order of observations. Okay, we'll check this option, labels, meaning we want to see labels with those variables, not just their coefficients. Constant is 0, I will uncheck that, so we'll see whether constant is significant in this model or not. Speaking about constant, I think giving this model, if constant is significant, meaning let's say we have a property that has 0 rooms, 0 bathrooms, 0 area, and the condition is 0, meaning like it's in poor shape, or well, actually it doesn't make sense, right, given this variable. But in theory, what I would like to say is that a non-zero constant may make sense because for example, if you're predicting price of a property based on square footage only, constant may make sense. Basically, says if it's 0 square foot, the property has 0 square feet, meaning the property doesn't exist. In that case, the value of the property can still be non-zero. The value of the property will be that constant, and that constant will probably represent the price of the plot or something like that. So we'll not assume that the constant is 0. Now, confidence level has to be specified at 95% range. That's the common confidence level. Again, I don't want to get into statistics, but basically, what you're specifying here, you're saying that you want to be 95% confident in your results, meaning you want to make sure that there's a 95% chance that whatever results that you have is a result of real underlying relationship and not due to some kind of randomness. And we will specify that we want output to be saved in a separate sheet. In fact, it's required for assignment 10, the last bonus assignment, that you save your regression output in a new sheet. Now, I'm not going to touch this. I'll just, here you have options for plotting residuals, standardized residuals, line fit plots, and normal probability plots. Those things are very useful when it comes to diagnosing the assumptions of regression model. In other words, when it comes to checking whether the assumptions of regression model that you're estimating are met or not. So one of those assumptions is that the residuals need to be normally distributed. But we're not going to go into that because those are like advanced topics of regression modeling, and the emphasis of this module is practical skills when it comes to building those regression models using Excel, and not necessarily on all those assumptions and theoretical explanations behind the regression models and the outputs of regression models. So we're just going to ignore it. We will concentrate on the practical side. So that's it. So we press OK. Okay. So what's the problem? So maybe it's values. So Y range is this. X range is this. Okay, so I'm not sure what the error was. Anyways, those are regression results. Now we need to reformat it a little bit to see like those label names, and also to see numbers better. Now what I will do, I'll just format numbers. I will specify those numbers as numbers with, let's say, 6 decimal points, because sometimes you need that kind of precision. And I'll copy this format for other numeric cells. Need to increase the size. That's a bit too much. The values are too large, but that's okay for now. So I'm just doing a little bit of reformatting so I can see those values better. Okay, well, once again, this is how you interpret the output. First of all, you need to look at R square. R square means the overall fit of your model. In other words, it tells you how much variance in the dependent variable, which is Y, which is the price of the property, is explained by your predictor variables, which is variables x1, x2, x3, and so forth. Now the R-squared that you have is very high. It's almost 100%. By the way, this rarely happens in social sciences, in anything involving humans and their activities, like economic activities. So I would be very suspicious about this number in real life because it's just way too high. But because indeed I generated those numbers using a fairly strong linear relationship, that's why it was able to find that relationship, and the R-square is so high. Now adjusted R-square is something similar. Typically adjusted R-square is lower than R-square. Adjusted R-square is the same thing as R-square. However, there's a penalty for introducing additional independent variables like those x's. Because if you introduce a number of, the greater the number of independent variables, the more fitting you can do. So there's that side effect of overfitting. In other words, you just try different combinations of those independent variables to create a model that explains pretty much everything, but it doesn't mean like it's a real model. So there is that side effect of overfitting when you include variables. In other words, the precision on that sample increases, but not necessarily for the overall model. As given that this model is trying to estimate real life. So R-square seems to be very high. The overall the overall model seems to be significant. In other words, this model doesn't seem to be like a result of randomness. It really seems to explain the data. So that's where the F-test is useful. Now let's look at the coefficients for our independent variables. Now the first thing you need to check is intercept. Now intercept has a certain value, right? Which is like what, $3,000, $3,583. But this value is not significant. The p-value is greater than 5%. So what it means, remember that confidence interval. What this means, it means that the chance that this value is a result of randomness versus being like a real value that explains the prices of real estate, is greater than 5%, right? Or in other words, our confidence in this value is less than 95%. So here it's like 63%, right? So in that case, we discard the coefficient. So now rooms, this is the coefficient in front of rooms. So basically for every extra room you have extra 10,000 that you're paying. The p-value is 0.0000, meaning it's less than 5%, meaning it's significant. Bathrooms is significant. For every additional bathroom you're paying extra $10,375. Seems to be significant. Here you have area in square foot. The coefficient is 86.9, which means that the price per square foot is around $86.9. And this value is significant. And then condition seems to be highly significant. For a property in good condition, you pay on average extra $21,865. So this is our model. Now, since intercept is not significant, what I will do, I will build the same model again. I will delete that sheet. I will build the same model again, but this time I will exclude the intercept term. So what I'll do, I'll just go to data again, data analysis, regression, the same kind of model, but constant or intercept is 0. So I'm doing this. Okay, this is our output. So again, R-square is high. This number seems to be significant. I will reformat p-values so that they're more recognizable there, like in that normal format versus scientific format. So I'll go to format cells, number, put 6 decimal points. So intercept is assumed to be 0. That's why there are no like significance testing. Now all those intercepts are here. So it basically says you pay extra 9,507 for extra room, extra 10,866 for bathroom, and the price per square feet is this, and there's a premium on condition. So the values are similar, but now without the intercept they're slightly different. Okay, so basically what it means that the model is good, based on adjusted R-square, based on R-square, it's significant, statistically significant, based on the F statistic, and all those coefficients, you have the value for those coefficients, and you have, p-value, meaning they're statistically significant. They're not due to randomness. We have confidence to believe in those values. So this is output. So here we'll just call it like regression output. or regression results. Okay. Now, based on all this, we need to build a decision support system or decision support model. So what I will do, I'll just copy. I'll copy this header from here. Okay. So this will be our model. We'll ask user to enter number of rooms, number of bathrooms, area in square feet, condition. 1 means good condition, 0 means poor condition, and here we're going to have recommended price as our output. Okay, so we'll let's say we'll put borders around it, and we'll just highlight this. I don't know, with yellow. Recommended price will be highlighted with yellow. Now, what I ask you to do, you need to write some kind of model explanation, brief model explanation below. So you'll just tell me, like, what is the equation that this model is based on? What are some of the assumptions that you made? Whatever you feel is necessary for me to understand in order to be able to use your decision support model. Now, your model is quite simple. I will not write anything, but I will just write the equation that we're using for this model. We're basically saying that y, which is recommended price, equals x1 times, going back to the regression results. By the way, x1 is what? Rooms, yeah. So for rooms we have this value, so we'll copy it. So rooms, didn't copy it. Rooms, we're going to use 2-point decimal precision. Rooms times this value plus bathrooms, which is x2 times this value plus x3 times its area in square foot, 8731, plus condition. So for condition there is a premium of $22,159.12. Plus condition, which is x4, times this value. So basically it means that if 1, meaning it's a property in good condition, we'll add extra $22,159.12. So this is our model. But I'm asking you for your assignment to write some verbal explanation as well. So this is like the mathematical model, and those are verbal explanations. So now what we need to do, we just need to plug in those numbers into this cell, recommended price. So what I will do, I'll just copy this formula and then I'll change values. So instead of x1, I'll put a1, that's the real cell. Okay, instead of x2, I'll put b2. I'm sorry, it's not a1, it's a3. And then we have b3. And then instead of x3, we have c3. And then instead of x4, we have d4. Okay? I'm sorry, d3. So this is our model. And what I will do, I'll just format this is currency with 2 decimal points. Okay? So let's say we have a property coming our way. Let's say somebody owns a property that has 3 rooms, 2 bathrooms. The area in square feet is 1,600, and the condition is very good. So the model tells us that the recommended price should be $212,110.36. Okay, so this is how this model works. By the way, I'll show you I showed you a very basic way, a very simple regression model. Regression modeling is a very powerful analytical tool. I mean, I'm sure like all those websites, first of all, regression is used heavily in recommendation engines. So based on certain parameters, they can recommend something for you. And the regression that they will use is a bit different. It's probably going to be some kind of logit regression where the dependent variable is the autonomous variable. For example, they will take your age, let's say credit limit, some other variables, and based on that, they will recommend something for you, or they will estimate the credit card limit or the loan amount that you're eligible for. So it's used in all kinds of applications. And also there's a famous website called payscale.com. This is the website where you can enter certain parameters of your job offer, let's say, or your own CV parameters. For example, you can enter your age, your years of experience, level of education, position type, where that position is and which location, and all those things. And based on that, they will tell you, well, we think that the fair salary for this position is this. So you can check whether you're being low-balled or on the opposite, you're getting low deal. So I mean, I don't know all the details, but I'm sure their estimation technique is based on some kind of form of regression analysis or collection of different regression models. So it's a very powerful technique, and I'd like also to say that this was like just for demo only. So we'll name this sheet DSS. I just wanted to show you like how to go about it. I'm sure there are better ways to estimate the regression model, perhaps by including additional or better variables, better predictors. Again, more predictors does not necessarily mean better model. For example, in this model, I only have 4 predictors, but the model has R-square of 96%, which means it's a very good model because based on very few factors, it gives almost 100% certainty prediction precision, right? So, it doesn't mean that you need to have a lot of independent variables to make your model good. And also, you can probably do some improvements in terms of usability, like formatting, what needs to be entered. And also, I'm requiring you that you write like a more detailed kind of qualitative explanation as to what's happening in your model and how to use this model. So this concludes our video presentation on building a regression-based decision support system in Excel. Thank you for listening.